Well, yesterday we talked about two scientists who had some pretty big contributions to the gases field. One is Boyle, and Boyle discovered that there was an inverse, indirect relationship between pressure and volume. If you up the amount of pressure, you need less volume. If you increase the amount of volume, you must then have less pressure. We're going to do a lab on this on Thursday, by the way. Basically, the idea would be, if I could kind of draw like a little scenario, his suggestion is, if you were to have, like, say, a sealed, it doesn't have to be an isolated system, but it should definitely be a closed system. If you have, like, a sealed container, and you have, like, maybe like a plunger, this is literally what we're going to use. And you can take this plunger and force it downwards by, like, pushing it down. If you add pressure, so your pressure increases, the volume would then decrease, because in the second picture, now this has been pushed down to here, right? Someone's pushed it down, all these molecules right here, well, they're just compressed closer together. Does that make sense? We call that an indirect or an inverse relationship. What you guys are going to see in our lab when we do this is it should produce a graph that looks like this. And I really like talking about this right now because I think almost all of you guys are in math with me, right? -1. Sorry, because I know you're not in my math class, but you can bear with this. Grade 12s, you guys should have learned last year about a reciprocal function. And grade 11s, you're getting to this in about a week, so it's almost perfect timing here. A reciprocal function looks something like this. It comes down like this, and then runs along the axis like this. Okay, this is a reciprocal function, and it has like a bit of decay to it. Okay. This is what an indirect relationship would look like. If this was, say, pressure and this was volume, what happens as the volume gets bigger? Well, as the volume gets bigger, the pressure gets small. So this is one of the functions that 20-1s will learn in, like a week and a half, basically. So, then the other guy you need to know about is Charles. Charles discovered that the volume would increase if you also increase the temperature. Or the volume will decrease if you decrease the temperature. All right, side story. This is one that really applies to me as a sports fan. Has anybody ever heard of the New England Patriots and the controversy known as Deflategate? Anybody ever heard of these before? Drives me crazy because I'm a science teacher and I love the Patriots. If you haven't heard the story, basically what happened is the Patriots were fined a huge amount of money because they cheated. But numerous scientists have come out and said they did not. Okay? But basically the concept is that the footballs needed to be inflated to a certain amount of volume and pressure. Okay? However, it was super cold out that day. And what ends up happening is when you take a football from a warm condition and put it outside in the cold, it is naturally supposed to get smaller. Right? When you decrease the temperature, it's supposed to decrease the volume, which also kind of decreases the pressure because, again, the reason why there's less pressure is it's colder outside, molecules aren't moving as fast. So it was like for the minute amount of difference, the pressure was supposed to be about 12.5 psi, and on average it was about 11.3 psi. So all sorts of scientists did studies and said, look, this is exactly what you'd expect. If you keep the footballs up indoors, they'd have this much pressure. Take them outside into the cold, they'd have this much pressure. But they ended up getting fined and all that stuff. But they ended up winning the Super Bowl anyways, which was cool. So, anyways, the basic concept then is that if it gets cold outside, the volume should decrease. Right? That is actually, that makes so much sense to anybody who doesn't work for the NFL. And I see this with my daughter's toys outside, or if we were to leave an inflatable toy outside. One year we left an air mattress, or an inflatable pool. We accidentally left one of those outside through the winter. And it's not that it had a leak, it's just that as it gets colder, it would shrink and shrivel up. Does that make sense? So same thing with tires and air pressure. So this is Charles's law. Here's how we're going to show this graphically. If you were to plot, say, temperature and volume on each axis, as the temperature increases, the volume should also increase. So we would call this a direct or a linear relationship. What we're going to do in our lab on Thursday is we're going to collect some data and do exactly like what I was showing the kids in Math 20 yesterday. We're going to collect some data on, say, volume and temperature. We're going to say, the temperature was 273 Kelvin. The volume was 5 milliliters. When the temperature was 290 Kelvin, the volume was 10 milliliters. When the temperature was 307 Kelvin, the volume is 12 milliliters. We're going to plot all this data. We're then going to make a graph with our calculator using like this. It's still on my calculator. You guys remember doing this yesterday? Where we're going to plot these points. We're going to get a nice straight line through it. And it will be successful if for the Charles law, if we get a nice straight linear graph, then we'll be successful. And if for the Boyle's law apparatus, we get a nice reciprocal graph, then that'll be success as well. Does that make sense? Okay, today's topic then. Well, someone had this really clever idea that, hang on, what we have is a law where we have pressure times volume equals pressure times volume. And then there was another law where volume over temperature equals volume over temperature. And you guys get where I'm going with this. Someone said, hey, let's combine them into the combined gas law. So I don't really have a lot more to add to this. It's just rather than there being either temperature volume or volume pressure, you now have 6 variables to work with. Okay? If I give you 5 out of 6 variables, you should solve for the 6th. You will recognize these questions because I give you a lot of information. Because I would have to give you a pressure before and a pressure after, a volume before and a volume after, and say one of the temperatures. And then you solve the remaining one. So like these ones are easy to tell because there's just so much info. I do have to point out a couple of things here. Although I wrote in the note right here that the pressure is in kilopascals, it actually does not have to be in kilopascals. As long as both pressures are of the same unit type, they would cancel. But that's the standard unit we typically would work with. Okay. Milliliters or liters would be the typical volume we work with. And again, it does not matter whether it's liters or milliliters, as long as both of these volumes are the same amount. But the one that has to be in a certain unit is temperature. It has to be in Kelvin. Okay. The reason it has to be in Kelvin, it has to be measured in a way in which negative numbers are not possible. You cannot have a negative mass. You cannot have a negative volume. Therefore, you cannot have a negative temperature. Does that make sense? It has to start at 0. So make sure you convert your temperature into Kelvin. So, without further ado, let's just try an example. And if you guys got yesterday, this really isn't that much more. Okay, so you've got a syringe. And we're going to, this is basically our lab, we're going to squeeze in the plunger so that rather than it taking up 150 milliliters, it's got squished in, and now it only takes up 65 milliliters. So really what I have here is a volume 1, and I have a volume 2. We also are going to give you some temperatures. The temperature is going to go from 21 to 23. This is temperature 1 and temperature 2. And then I'm going to give you the initial pressure. Our goal is to tell me what the final pressure is. The 2 things you do have to do before you start though, these 2 temperatures have to be converted into Kelvin. So add 273. So 273 and 21 would give you what? 294 and 296 Kelvin. Did I mention yesterday that Kelvin does not have a degree symbol? Is that something I pointed out? Yeah, we only use degrees for Celsius and Fahrenheit. Kelvins are not considered a degree. I don't know why, but I mean, I guess it kind of makes sense that like we don't talk about degrees of mass or degrees of volume. So. Anyways, let's go try V1 times P1 over T1 equals V2 times P2 over T2. Throw in your numbers. 150 milliliters times 105 kilopascals divided by 294 Kelvin gives you 65 milliliters times an unknown second pressure times 296 Kelvin. One of the things that I really try to do in my math class, because I teach you guys both math and chemistry, I try to be very purposeful in the order I teach things in. This is why grade 11s, everybody did rationals first. Because that's what this is, right? I'm asking you to solve a rational function. So how do you solve a rational function? What's the key to solving an irrational? You need to cross multiply. Yeah. Okay. So cross multiply like this guy up there, this one up here. And then like if you get it, you can also divide by the 65. But if you want me to show you all the steps, you now are taking 150 milliliters, you're timesing by 105 kilopascals. The 296 is also coming up. Then over here, the 65 milliliters is there, the pressure is there, and the 294 is coming up this way. So that's the cross multiply bit. And then once you've done the cross multiply, this P2 right here, you need to get rid of the 65 and the 294. So then you need to divide by 65 and 294. If you know how to do this, I don't need you to show me all the little steps, okay? Like, I am cool if you go directly from this to your final answer. Okay, like if you understand the rationals bit. So, I don't have a calculator. Finish it? What'd you get?
244.
244? Okay, and then in terms of units, milliliters cancels, kelvins cancels, so that'd be kilopascals. That won't be correct, will it? No, it will. Because this has 3 sig digs, that has 3 sig digs, this has 3 sig digs. I think I've talked with a few of you guys about the Celsius to Kelvin issue. Let's say that this did not give you 0.0. Let's say it just gave you 21 degrees Celsius. That's not 2 sig digs though. On the absolute value scale, this 21 Celsius was actually 294 though. So even if there wasn't a 0.0 here, it would have counted as 3 sig digs.
With the 0, was it 4 sig digs?
Well, the way that works though is that 21.0 has been added to 273. And so in doing that, the way that you add is that you have to cut off at your lowest precision marker. So it's because of that. Now it depends on whether we're being picky. Technically it's 273.15. So in theory, you actually could have added that right there and cut it off at the 10th. And you could have called it 294.2 actually. Does that make sense what I'm doing there? Because this 5 right here would actually round this up to like a 2. But for the most part, due to precision issues, we normally don't bother with the 0.15. That makes sense. So, yeah, based on just adding 273, we keep it at 3 sig digs. So this is very murky area, the conversions between degrees and Celsius, because the real world loves to work with degrees Celsius, because that's really all we know, unless you're American, and then they have to put Fahrenheit for some reason. But like the scientific world is always in kelvins. So they pretty much like, it's just better to not bother measuring in degrees Celsius in the first place and just go right to Kelvin. Okay, any questions? Okay, so I feel like it's fairly straightforward. Okay. Really what I'd recommend for you guys then is you just need practice. So I've got 3 different places you guys can practice. 1, I've got more questions here. All right. So if you want to try these ones, feel free. 2, there is a worksheet that I put online. Where is it? This one here. If any of you printed it, called the Gas Laws Practice Questions, where I just have tons of practice questions. Okay. And then 3rd, you have your assignment. Okay. Now the only thing that's actually for marks is your assignment. So what I would recommend is today and tomorrow essentially is work time. Okay. I would say first thing I would do if I were you guys, I would work on my assignment as far as I feel like I'm able to. So whenever you get to something that I haven't taught you yet, then I would stop. But then I would keep practicing just for the sake of building repetitive skills. The last thing I would recommend though, print off your labs. I know we're not doing the lab till Thursday, but you can probably start answering some of the lab questions. So anyways, I'm kind of done now. For the next day and a half is work time. Kind of make sure this is solidified. We're actually halfway done this unit. There's only 6 set of notes, and we've done 3. So this is very much like physics. So like for you guys that did physics with me last year, it's basically like formulas plug and chug. If you're not overly strong at the algebra yet, then get some practice. Oh, any questions? Okay, I'm done. 14 minutes.